and perhaps finish with questions about this morning, anything that you didn't get or that you have questions about or that he might have missed or whatever.
I would just like to have some more examples where you use object-oriented ideas, where you use classes and objects, like how you attack a problem with this rather than procedural and functional language. Like what are you doing with power building, like stuff like that?
Okay. Let me just try to think of a good example where, actually, maybe I'm going to, why don't I, instead of that, give an example of something I'm doing in Java as my teaching myself Java project, which, if David doesn't keep me too busy with other things, I'm hoping eventually to have posted so that people can look at it, because it's a medium-sized project, so you can kind of look at it and understand what's going on without being overwhelmed, but it's rich enough that it has a lot of the important features. In particular, it has a lot of the important features because I wanted to make sure I actually got to learn the things that are important. It's something similar to what I was told you were doing with the Scheme project. It's sort of a dungeon game. There are rooms and there are creatures in the rooms, and the rooms and the creatures are all objects, and the passages between them are objects. And those are sort of concrete objects. You can see the room and see the properties it has. It contains a bunch of other objects. There are also objects that are not concrete. For example, there's time. There's an object that keeps track of what time it is in there. And I'm using, this is a good example of something for object orientation because all the things share certain properties. For example, they have names, they have locations, they have other things that are contained within them and that they know that they're contained within something else. And some of the objects are what I call wanderers. They move from one room to another. And so that's a kind of object. And within wanderers, there are some things that are just ordinary wanderers, like there's a bouncing ball. And then within wanderers, there are animals. And animals have the additional property, in addition to that they move from place to place, is that they also eat things. And some kinds of animals have special properties. So not only do they do everything that animals do, but, for example, the mouse gets caught in the mousetrap and it escapes from the mousetrap. And the cat meows sometimes, and the dog barks. And the dog follows things when they go from one room to another. So by using object-oriented programming, I'm able to say for the dog just that it follows people, and everything else that it does is the same as a generic animal. And that would be a lot harder to do with a traditional procedural language. The other thing that object-oriented programming languages do for you is they let you isolate a little bit of code, and they will sort of call your code, and it sort of feels this way when you're programming it, especially in a graphical user interface environment. You put a little bit of code here, and you tell something when your code should be called, rather than having to do all of the driver stuff yourself. For example, the dog following creatures, there's a subroutine that gets called whenever an object leaves the room that you're in. And the Java runtime environment will automatically call that subroutine on the right object class for each object. So you don't have to worry about that level of detail yourself. You just say, okay, this is a dog, these are the dog's properties, and then you say, call the subroutine for every object in the room, and the Java runtime environment will say, okay, this one's a dog, so we'll call this method for the dog, and this one's not a dog, so we'll call a different one. And you don't have to worry about those details. It makes it a lot easier to write that kind of program. Some of what I said may have been a little bit vague because you haven't gotten to a lot of the concepts yet in lecture to make that a little bit more real, but hopefully it gives you some idea of what object-oriented programming does for you. I'm also going to give one other example that in terms of debugging programs, everybody who writes programs makes mistakes, and you're not necessarily any less likely to make mistakes writing in an object-oriented environment, but it can be easier to debug them. For example, in a traditional programming language, you're actually, I'll do the object-oriented one first. You have an object-oriented car, and you're driving the car, and you press on the accelerator, and the car goes backwards instead of forwards. That's hopefully a relatively easy thing to notice and to fix. Whereas if you're using a traditional procedural language, especially a compiled language, you might have the situation where you're driving down the road, and you press on the accelerator, and your toaster goes on back at home. And that's a lot hard, you know, you're out on Route 2, and you don't even, you know, somebody else is back home. They notice the toaster going on. They don't understand why the toaster is going on, and you don't see anything wrong. So hopefully, with this kind of environment, the errors can be localized to where the actual bug is in the code, and that makes them easier to find. There's another thing that's often cited about object-oriented programming, which is code reusability. My feeling is that you can get good code reusability in any language as long as you do it right, you know, and that you don't make you separate out the different parts of your program into sensible sections, where what that exactly means depends on the language you're working in. And so one of the things that you learn with experience is how to break up a problem into sort of the building blocks and then the special case stuff. And if you do that right, then you have good building blocks that you can use again the next time around. For example, I had a project where I was creating HTML files for documentation of a particular software package, and it was basically kind of like JavaDoc, which you'll learn about, which automatically creates HTML documentation from your Java files. This sort of does the same thing for PowerBuilder files, and rather than just embedding all of the HTML syntax in the program that was doing the syntax parsing of the PowerBuilder code, there's a separate object which basically knew all about HTML, and it had methods such as start a document, include a hyperlink to this document, here's some text I want it to be bold, and stuff like that. So that's all separated out, and that's a building block that could be used if we were going to generate HTML for some other purpose. And there's nothing object-oriented about that, really. You could do that just as easily in C or Fortran or something like that. But it is an important thing to do, and maybe it's a little bit easier with object orientation. Okay, any other questions about this morning? Do you remember anything about this morning? David said he talked about the various access levels, public, private, and protected. Is that? Okay.
The business of public and private seems as though, I mean, in practice that comes about because you're accessing things in different files or whatever, because obviously if you see that the source code, whether someone writes private or public is irrelevant, so you must be accessing.
Yeah.
In which case, how would you go into a class and say, what are all the public objects, a class that you can't see, and say, what are all the public properties of this class?
Well, hopefully it's documented. There are mechanisms, if you need them, within the Java language to make those kinds of inquiries. But if for example, you buy a 3D graphics library from some vendor, they're going to ship you the class files, and they're also going to ship you the documentation. And so you look at the documentation, and that's how you find out what the public stuff is. If you're lucky, or if you're picky, they'll also send you the source code, and you can look at the source code and find out what the public methods are. One of the things I wanted to talk about with regard to public, this is somewhat related to public and private, has to do with accessor methods. Suppose we had the Vector2D class that David created, and did he talk about the getX and getY methods? And you might be wondering, why do we go through that extra effort? Why don't we just say object.x and object.y rather than having to write these extra methods? And here's an example. Suppose you're writing some software for a Little League, and you have to keep track of the ages of all the kids in the Little League. So you have an object that's a kid in the Little League, and one of the properties on that object is age. And you have a bunch of other code elsewhere that, and supposing you didn't have an accessor function, getAge, you just made it a public variable, and whatever script needed it said player.age. And then you realize that every time a kid has a birthday, somebody has to go in and change their age. And that's not particularly efficient or reliable method of keeping track of kids' ages. So you decide that what you really want to do is keep track of their birthdays instead. And so you create a new property on the player class for birthday. And now you have this problem that you have all these other scripts out there that are trying to refer to age, and what you have instead is birthday. And it's a problem. If what you did from the beginning was to make age private, and you had an accessor function, getAge, that returned the value of age, all you would have to do now is change your accessor function, getAge, to compute the number of years between today and their birthday. So by concealing the implementation of age from the external world, you can change it however you want. And as long as you keep the interface the same, you don't have to worry about what effect you have on everybody else. Another reason is if you have your properties being public, then somebody can go and change them and make them invalid or inconsistent. If you had both birthday and age, then somebody else who is careless could write code that changed. Maybe they didn't know that you had both age and birthday, and they were just changing age without changing birthday, and all of a sudden it didn't match up anymore. So by making your properties private and creating accessor and mutator methods. Mutator methods are one of the things David wanted me to talk about. Mutator methods are basically things that change the properties of the object. You basically protect your object from somebody else messing it up. so somebody else could be you on a day that you forgot what you had done the first day. I've certainly worked on projects that are big enough that I can't remember all the details, and so it's nice when the compiler can remember some of them for you.
How would you then, in that instance, you've suddenly realized you need a whole set of birthdays for your 87 kid objects, instances of the kid object throughout there? How would you then populate all of those?
Well, we're kind of fuzzing the different. Is this in a database? Normally what would probably happen is you'd have a database, and you'd be loading the database into objects, the question doesn't. You're not going to have a situation where the program is actually running and the objects are out there, and you're changing the architecture of it while the program's running. You might have it in a database, and you change the database, and then you change the things that load from the database into your objects, or something like that. I guess the database could just be a file in some cases. Yeah.
I would appreciate more information on the constructor method. The one you went through this morning, you seem to refer to the variables. Do you have to initialize the methods, or I guess the whole thing is a little bit vague to me. When you call this constructor method, it just says this X is X. But what about like the methods? Is that enough?
The methods are already there. The methods don't change. They're part of the class, and they're already there from your source code. It's the thing that's getting created when you create a new object is the stuff that's different from object to object. So if you have a method, all objects in the class, the method is the same, so you don't need to do anything special to get them set up in the constructor method.
Are they replicated, or what are they?
They just exist once, and then when you call a method on an object, the runtime environment finds where that particular code is and runs it. And sometimes it's on that object, and sometimes it's on an object on a different class that you inherit from. How much has he mentioned that? Yeah. Sometimes it's tricky to talk about things with. Okay, so at least I know that you don't know what it is, and I'll see how I can tiptoe around it. So you basically say that you want to call a method, and the runtime environment finds where the code is, and it runs that method. And so you only need one copy of it.
But there's a new object with new variable values created.
Right. There's a new object with new variables, and the constructor method can, in principle, do anything, just like any other method. Normally, what it does is that it initializes the properties of the variable that you're creating. But, for example, you might have a situation where you have a hospital system, and it interfaces with other hospital systems. So every time you create a new patient, you want to send a network message to some other system saying, we've created a new patient, this is the patient's name, these are some other vital statistics. You could perhaps put that code in the constructor method of the object so that every time somebody created a new patient object, it would automatically send that information. So no matter how many different programs had code that created new patient objects, it would automatically send the required interface information to the other hospital systems. That might be a reasonable thing to do in a constructor, other than just initializing the values. The constructor might also check that the values that are being passed in are reasonable and consistent. If you have a date object and somebody passes in, you have a constructor that takes the month, day, and year, and somebody passes in that the month is 13, then that's not valid, and you can check for that in the constructor and complain in an appropriate fashion when the values aren't okay. let me see if I can say anything about protected without talking about inheritance. I'm not sure if that's possible.
Why don't you introduce us to inheritance ahead of time?
Keep that open as a possibility. I think David probably has a good plan for how to introduce you for inheritance, and I don't want to try confusing you too much by doing it on the fly. So maybe we'll just hold off on protected, and it's a keyword that actually here we go. Protected is kind of like private, but it lets certain related classes see the variable or method also, and related, similar. I guess similar is probably better than related. Lets similar classes see it, and when you learn about inheritance, you'll understand what kind of similar. And don't press me on it. Any other questions on public and private?
Is there an equivalent to, the exact name is going to escape me, but what in C++ you could define functions that don't exist until they exist and inherited? Or
Yeah. Yeah, there's a couple ways of doing it. There, you can have an abstract class, which is a class that has some methods defined and not others. And you can't create variables. You can't create objects from an abstract class because it doesn't know what to do. But you can define the class. And then you can also have what are called interfaces. An interface is essentially a completely abstract class that, or close enough. It has no code at all, but it says these are the things that this interface can do. And then later on, you can define classes that implement the interface. And I think that's Friday that you'll learn sort of the details about how that works.
And that would be how other people could use, I mean, by interface, you mean somebody writes a class that implements add the interface, and add the interface has various functions attached to it that don't actually do anything, but they give you a way to, it's kind of like documentation.
The fact that you have a bunch of different classes that have the same set of functions allows for certain generality in other code that calls those classes. And we saw, for example, system.out.println yesterday. I suspect, although I haven't actually seen the documentation, that out is in some class that implements an interface, and the interface one of the methods on that interface is println. So depending on whether you're outputting to a console or to a file or to a mag tape or to the internet or something like that, the code might be completely different for how you would implement println. But since it's a defined interface, you can say system.out.println, and regardless of what out actually is, as long as it's known to implement the interface that supports println, then that would work. So that's an interface that you've sort of already seen. Okay, let me mention a couple other keywords that you can put on methods and on properties. One of them, did David mention the final keyword? No. Okay. Final can be used on classes and on properties, and I'm not sure if it can be used on methods or not. But I guess it doesn't really make, if you don't know about inheritance, putting final on a class doesn't really tell you very much. So we'll talk about putting final on a variable. That basically means it's not going to change. So, for example, we can say final int days in week equals 7. And we know that the number of days in the week is always going to be 7, and it's never going to change. And in some, there's a couple reasons that you might want to do this. One is for the sake of the person looking at the program, they could see that this is intended as a constant and not a variable. A second reason is to prevent subsequent errors in coding. If somebody later on inadvertently tries to change days of the week, then you'll get a compiler error saying you can't do that. And a third reason is that it can occasionally allow the compiler to generate more efficient code. This is a sort of simple example, but if to the extent that the compiler knows, way down here that days of the week is still going to be 7 no matter what happened in between, then it might be able to generate slightly more efficient code. But these days, programmers are a lot more expensive than CPU chips, so speed efficiencies are not nearly as important as the fact that it helps cut down on errors and aids in documentation. Any questions about putting final?
So it's just essentially defining a constant.
Right. Now, one thing you have to be careful of, supposing we have final final vec2d foo. This define, well, I'm not sure that's, yeah. I don't know if you can, no, I'm confusing myself. I'm not going to do that. Never mind, sorry. Can you rewind the videotape? Let me say a little bit about what I was trying to do, and maybe you can understand my, if there's a difference between when you have a variable that contains a reference to an object, the variable may forever continue to refer to the same object, but the object itself may change. For example, there's only one person who's ever going to be my mother, but she could have changed her name, she could change her age, she could change her hair color, whatever. So and I'm not sure syntactically about that, so I'm not going to put up any syntax on the board, but it's just something to keep in mind in certain cases that when you're programming, that just because the reference doesn't change doesn't mean that the things it's referring to don't change. Okay, the other keyword is static. And that can also apply to methods and to properties. And what static means is that the method or a property belongs to the class as a whole rather than to the instances of it. So some of the examples that David gave, did he talk? I think he talked about static, yeah. And he mostly talked about it with regard to methods rather than to variables. So you might have a class that where every instance of the class had an ID number. And you could have, in the class, you could say static int last ID number. And in the constructor event, you would increment this value and put it into the ID field of the new object. And since this says static, it's part of the class. So let me and then in the constructor we have actually we have static last ID number, and then we also have int ID number, which is not static. So we say ID number equals lowercase l. So what this does in the constructor event when you create a new foobar is it increments the last ID number and assigns it to the ID number for this instance. And one thing to keep in mind is that as objects come and go, you're going to end up with gaps. So this should not be used for things where you want to keep track of how many are there that actually exist without certain kinds of other programming that we're not going to get into. But it can be used, for example, to generate unique numbers as you go along. So that's a simple example of a class, a static or class variable.
And then will your previous instances then the last ID number will change in all of them?
There's only one. There's only one place where this is stored. So if you have any code somewhere on some other method that refers to last ID number, no matter which instance looks at last ID number, it will see the last ID number. They'll all see the same thing.
Is static a good name for that keyword?
No.
Is it
not to me, maybe to somebody else. I wasn't there.
I think it's borrowed from C. That's the same semantic idea.
Okay. I wasn't there when they picked it for C either. And this is a concept that you would see in other object-oriented languages as well, although the syntax and in some cases you might have, for example, PowerBuilder doesn't have a keyword static. It just has a separate place where you declare class variables as distinct from instance variables. I think. Okay. Any other questions about this? One other thing I would mention is if you have a static method in a class, then it can only access static properties of the class. For example, if we have an accessor function on foobar that's get last ID number, that could be a static method, and it would return the value of last ID number. If we tried to write a static function get ID number that returned this, you would get an error from the compiler because you might not have any objects at all at that particular time that had ID numbers, and if you did have them, it wouldn't know which one to return. But there's only one of them, so you know which one.
Can you do it the other way around, though? Can you have an instantiated method that refers to static?
Yes, the static variables are always there and always available. The properties that are not static, that belong to specific instances, can only be accessed when you have an instance. Now let's put these both together. You probably actually write static final int days and week because that's a class constant. There's regardless of which foobar, well, this is not particularly in the class definition, but let's put it into the class definition. So it doesn't matter which instance of foobar you're looking at, days and week is always going to be 7. So we're going to call it static and make it a class variable. And there's a convention, which Java also took from C, that you make constants all uppercase. And that's how you know they're constants.
Every time you have a new class, you have to put that in?
Not necessarily. You can refer. It depends on what the access is on that. If we wrote private static final int days and week, then you couldn't access it from other classes. But if we had public static final int days and week, then you could have some other class that said foobar dot days and week. This is particularly useful if you have a public class where you want people to pass constants into you. For example, suppose you had a scheduling class and there is a method where you're supposed to pass in a day of the week. You could define each of the individual days of the week. For example, Sunday equals 0, Monday equals 1, etc. And then if somebody was calling your method, let's assume this is part of foobar, because we've already defined foobar, foobar.schedule class, then you would 15 meaning 3 o'clock or something like that. So this way, it's clear from the code that you're scheduling the class for Monday, and you don't have this problem of passing in a 1 and somebody who reads the code doesn't know that 1 means Monday. And you're also protected from typographical errors. If you passed in a string and you typed it wrong, then you would find out at some random time later when something went wrong. Whereas if you mistyped Monday, or more likely if you mistyped Wednesday, the compiler would immediately complain about it because foobar when misspelled Wednesday would not be a known variable name, and it would complain about it.
15 stands for 3 o'clock, what's the 0 stand for?
Minutes. This isn't a real method, but I just wanted to put something else on there besides the day of the week.
Would you reference that with the instance name or with the?
With the class, because it's a static.
Can you reference it if it's with the instance name?
Yeah, you can. Just as from the instance, you can reference it. So if you happen to have an object of that type, you could just use that.
So why did you choose to use the static on the final? You have to do that?
Well, if it's final, you might as well make it static, because if it's not going to change, then all the instances are going to have the same value. But this sort of emphasizes that it's part of the class. It's related to the class and not to any particular instance of the class.
In theory, you can leave it out.
Well, if you left it out, then you couldn't do this from some other script, because you'd have to put in a specific object here, and maybe this is probably a static method. You're creating it's a method to create a new class, so it's a static method, and it wouldn't really make sense to force you to have a instance reference here in order to refer to the Monday. So in there might be cases where you could leave it out and it would work, but in practice, if you do have something that's really a constant and it belongs to the class, then you would declare it static.
And that also keeps you from having, you only have one place in memory where this thing lives rather than one that's associated with every single instance you create. That's
true too. It does save a little bit of memory, but like I said before, Silicon's cheap, programmers are expensive, so that's less important than the fact that it doesn't confuse programmers. There are a couple things from yesterday I just remembered that we sort of left open that I wanted to get back to. One was whether you could ever say this, and the answer is no. I tried it. Even if you have something that's really a constant like this, the fact that it is syntactically a variable doesn't let you do it. So you have to do it in 2 steps. And although I think, and I didn't try this one, I think you can combine this as you can with other initializers. Equals that. So it's still 2 steps. You're defining the array, you're defining foo as an array, and then you're initializing it to this, but you can't use the shorthand of that.
Did you try that for final also?
I'm sorry?
I mean to say a variable, I guess.
Even if it's a static final variable, the fact that it's syntactically a constant, syntactically a variable, even though it's logically a constant, the compiler won't let you do it. On the other hand, in a switch statement, which we talked about yesterday, the cases there, you can use variables as long as they're constant. Even if they're not constant. I know you can do it if they are constant. So just a reminder, we had switch expression. So we could have something like this. Case Monday. Etc. Where Monday and Tuesday were defined like up there. So this would work. Any questions about this part? The other open thing from yesterday was about exclamation point and hat. And this is not, and this is not. I mean, it's not. This is exclusive OR, which will actually come in useful in problem set 1. You don't have to use it in problem set 1, but there is a place where it's useful. Exclusive OR. Do you all know what, I'm not going to force somebody who doesn't know to embarrass themselves by saying they don't know. Exclusive OR is a Boolean operator that's true if one and only one of the 2 operands is true. So ordinary OR is true if either of them is true, and exclusive OR means that one but not both. Okay, so we had a little bit of a digression there. I think we're done in terms of putting adjectives onto this poor thing. Question?
I'm going to need to know how to use these bitwise operators in masking things. I didn't get it. There are places where you need to know about that. You don't need to know about it for problems for the problems on problem set 1. I'm not sure in terms of the exercises, but I can go over it briefly. Is there anything that's up on the board that people, before I erase anything, is there anything up here that people have questions about? And the other thing is David put this up. Does everybody have this? So I can erase it if I need the space. Okay. Okay, so are there any other questions about this before I get to the bitwise operators? Okay.
Alan, maybe before you do it, can I just quickly review why static, where it comes from C, because it might help.
Okay, great.
Get this idea. In C, before C++, when you declare a variable, you declare it inside a procedure to make a local variable. So procedures have these local variables that you use, and nobody can access them except for the procedure itself. No other procedures can access those local variables. Now those variables, for the most part, when the procedure gets called, they get created and they exist, and when the procedure is finished being called and it returns, those variables are gone, and nobody can access them anymore, and that's called the lifetime of the variable. But there are occasional, it doesn't matter, no one needs to hear it.
How about if I finish?
Okay.
Because I know where you're going.
Okay.
Thank you. Okay, but there's occasional times when you do have some piece of information that you want to carry over from one invocation of the procedure to the next. For example, if we go back to this example where we had a last ID number, you have some procedure that, say, is processing transactions, and each transaction needs to get stamped with a unique number. So you would have this C use the keyword static also. You say static in last ID number, and each time you go through the procedure, you would increment the last ID number, use that ID number to stamp the transaction, and since it was defined as static, the previous value would still be there the next time through.
But you still wouldn't want any other procedure to touch that value. You want just that procedure to be the accountant for that value. So it's still local, but its lifetime extends over many calls of the procedure.
So if you think of this procedure as part of a class, as you go from C to an object-oriented language like C++ or Java, let's think of the procedure as being part of a class and being a method on a class, so that this is sort of a class variable, then it makes sense to call it static.
So it persists even without the creation of particular instances of the object. You don't need a particular instance of the object to have that variable exist. It has its value regardless of how many objects you create or destroy. Although I don't think David's talked about destroying objects, right? I mean, in Java it's automatic. When your objects are no longer able to be referred to, they get garbage collected, just like in C. That's one of the big virtues of Java, is that you don't have to do that yourself. In C++, you do that yourself. You dispose of the objects that are no longer pointed to yourself, and if you don't, you get a lot of garbage hanging around, and you can crash your system.
But don't worry, you can still crash your system in Java. You just need to come up with different ways of doing it.
And that's what this course is about, how to crash your system.
Okay. want to go on to the bitwise operators. And a little bit of a disclaimer, although I understand the bitwise operators, I haven't used them in Java, and I'm not sure about the syntax.
When would you use them?
Well, suppose there are a lot of, let's say you're running on MS Windows and you've got some stuff that you know is running on MS Windows. So you're writing operating system specific stuff. There are a lot of functions in the Windows kernel that take binary values where each bit position has a particular meaning. And if you're interfacing with those, then you tend to need the bitwise operators. So any number, do you guys all know about binary numbers? Okay. So let's suppose we have two binary numbers. Let's see, 40. Okay. That's my age. And that's some other binary number. So these are two binary numbers, and we'll call this one A and this one B. And if we have let's change this to 0 so that we have all the combinations. If you have a bitwise AND, the bitwise AND is true only, so A and B, only if A and B both have a 1 in the matching bit position. Just so a logical AND, you're just thinking about one bit on each side, and A and B is true if A is true and B is true. And the bitwise AND just applies that bit by bit to each bit. And similarly, A or B is true and exclusive OR. Who wants to read off what A exclusive OR B would be?
0, 1, 1, 0, 1, 0.
Looks good. So this, the first one is 0 because these are both true, so that's not an exclusive OR. The next two, exactly one of them is true. Both false, and exactly one of them is true again. So this is A exclusive OR B. And then there's not, and I don't remember the symbol for bitwise not. Somebody?
Is it exclamation?
Does that? Yeah, I thought it might be a tilde. Thank you. So this is not B. Everywhere where B has a 1, not B has a 0. So generally, if you're writing a standalone Java package, you probably wouldn't ever have occasion to use these. But Windows and I think a lot of other outside things do use things where the bit positions are significant. In order to interface with those, you need to do this. Okay. What? Page 57. Okay. Okay. It's right. So it's the syntax in the book is n and 8 divided by 8. And let's rewrite this as n and the subscript this is not a syntax that Java supports, but it is a syntax that the Blackboard supports. So rewrite 8 in binary. These are all written in binary too, so I'm just writing 8 in binary. So we're doing a bitwise AND of n with 1, 0, 0, 0 binary. So for example, if we had A and 1, 0, 0, 0 would give us 1, 0, 0, 0 because this one matches. And then we divide it by 1, 0, 0, 0 and we get 1. Whereas if we did B, that has a 0 here, so when we AND that with 1, 0, 0, 0, we get 0. We divide it by this, and it's still 0.
Is there any reason you write it out as binary?
I'm writing it as binary here just so it's easy to...
Second time?
Because we're still working binary. And just...
I guess Java actually cast it through.
It's this many. And it doesn't really matter whether we use this notation to write it or that notation to write it. It's still this many.
And masks out the particular bit.
Right. So we're using the AND to mask out the particular bit. In the division, we want the answer to be 1 or 0. If we just do the AND, the answer will be either 8 or 0. And if we want to get it to 1 or 0, then we have to divide by 8.
The division knocks off the last 3 zeros.
Are there
I'll-
shift
Or the last
operators?
as many zeros as you want if you divide it by, right.
In this case,
There's a question, are there shift operators? And there's an answer, yes, there are. So that would be, you could also write this in a couple of different ways with shift operators. You could shift it to the right 3 bits and then AND it with 1, or you could AND it with 8 and then shift it to the right 3 bits. You could also write n and 8 greater than 0, or not equal to 0, which would give you a true or false if that's what you wanted. So
And these bit operators also, if these represented sets, these bit strings, then all the bit operations represent set operations, like intersection.
right. So and is set could be considered as set intersection and or is set union and exclusive or
symmetric difference.
symmetric difference, yeah, and not as complement.
Okay, do the next example then did it with the shifting. Do you mind just like walking through that?
Okay, when you're going up a steep hill, okay. Okay, this is in some cases a better way of writing it than this, because you look at the 8 and you wonder what's the 8 doing, especially as the numbers get larger and larger and you don't necessarily know what 2 to the 13th power is, and you're not sure if you wrote it right. This is the shift left operator. So it starts with 1 and it shifts it left 3 bit positions. So the 1, after it has been shifted left 3 bit positions, is 1, 0, 0, 0 binary, which happens to be 8. So this is equivalent to this because we've taken the 1 and shifted it left 3 bit positions. And dividing by 8 is equivalent to shifting it right 3 bit positions at the end. So we have either 1, 0, 0, 0 or 0, 0, 0, 0, and we shift it to the right and lose the 3 zeros at the end. This is also another good case for some class having a final static. And who knows what that 8 means? Is it even really supposed to be 8, or is it supposed to be 16? So hopefully, in a real-world example, somebody would have defined, whatever, use French button names or whatever the 8 is supposed to mean as 8, and you would just use that that constant here, and so the person who is reading your code would know what you were doing, rather than if you just use the number 8. Similarly, if you had some situation where you wanted to use 2 of these things together, and you write down, well, let's say it's 16384 is 2 to the 14th and 32, and then you have 16416 in your program, and this is worse for 2 reasons. And even assuming I did the math right, if you have the logical name there, then somebody can understand what it's doing. And also, supposing that you want to change every occurrence, or at least find every occurrence of a particular bit flag. Well, supposing you search for every occurrence of 8 in your package, you're probably going to find an awful lot of them, most of which don't have anything to do with this particular bit flag, whereas if you use a logical name, you can find them. 16384, you won't have quite as many false hits. But now suppose you have 16416, because you're using both of these bit flags, and you're searching for 16384, you're not going to find it at all. Whereas if you used, whatever flag name or other flag, whatever they may happen to be, I'm assuming that these actually have, I'm not doing a good job of thinking of good things that these represent, but where this is defined as 16384 and this one's defined as 32, then somebody comes along and first they can read them, and second they can search for them. And you don't have to worry about whether you added these correctly or remembered the powers of 2 correctly.
This n and 8 over 8 or all the other different permutations, what are we actually doing? We're figuring out if n is between 8 and 15 mod 16?
Yeah, but, in going back to the Windows example, every window in MS Windows has a bunch of bit flags that describe certain properties of the window. And you can give a Windows system call that will return this list of bits. And you don't care about most of them, you care about one of them. And so you've got this list of bits. And it's not a number in the sense that you're going to add things and subtract things and multiply them. You don't really care about how big it is, you just care about the individual bits in it. So it's not so much a matter of is it between 8 and 15 as does it have this bit set, which means that the window has a particular property and we want to interact with it in a particular way.
Wouldn't you just use a method that you could pass as a plus?
It depends. If you're interfacing with Windows, Windows doesn't have that method. One thing that you could do if you were writing a Java package that interfaced with Windows and you're expecting to do this kind of thing a lot, or even if you were only expecting to do it once and you wanted to try to be as modular as possible, is you could write a method that all it did was it passed the window handle to Windows, got the value back, and did this and returned true or false. It still has to happen someplace. But yeah, that ideally the end application programmer isn't even going to have to worry about stuff like that. In a lot of languages, in non-object-oriented languages, it can be convenient to pack a lot of information into 16 or 32 bits, not just to save memory, but because those languages provide primitives for assigning and manipulating and passing around a 16-bit or a 32-bit integer, whereas they don't provide primitives for passing around large collections of things like Java objects. So in order to make it more convenient to pass these things around, they pack everything into one word. Whereas if you were writing it in Java to begin with, you'd probably just have a bunch of Boolean properties on an object, especially if you work for Microsoft, where the goal is to make your product take up as much memory as possible. I don't know if you know, they have a deal with Intel where Microsoft tries to make things require as much CPU as possible so that people have to buy faster processors from Intel. At least that's what it seems.
In Java, is anything that isn't 0 true? So did you actually have to divide by 8 in this example to get the proper Boolean answer?
I'm not sure in Java.
I think in Java there's only true and false, right?
The question is, if you wrote
If you wrote if 7, then it's going to execute the next state.
okay. So the compiler, so in an if statement, the compiler will coerce integers into Booleans, essentially. So if you could write, in some context, if n and 8.
That's not as good as error.
That will work properly. But if you want to assign the result to a value, then you would need to do the shift.
I thought that it has to be a Boolean there.
I'm told that it doesn't have to be.
I think I read it has to be in the book.
Well, whether it is or not, it's really, it's annoying programming style to see a lot of stuff like this. Right? I mean, you wouldn't want somebody to program like this all the time, with lots of comments about how it saved them one line. And made you work for an hour to figure out what it meant.
Can't we simply have a function B7 for the value of the 7th bit?
You could.
You have to use these operators in order to get at within the function.
Is there a shift right arithmetic where it's sign extends? Do you know? Does anybody know?
The 2-arrow version does sign extension. The 3-arrow version does zero fill.
Okay. So it does both logical and arithmetic.
Yeah. I'm not sure what the 4-arrow version does.
Don't ask.
It serves you a drink, so you don't really care which one it is.
Okay. Anything more here? Okay, when I talk, I'm going to do one thing that's real quick, which is the online documentation. If you ever have a question about, well, actually, before I get that, Java differs from some languages in that it has very little syntax and a huge amount of libraries and built-in classes. Probably by the end of this week, you'll have learned, or at least been exposed to, pretty much all of the Java syntax that you're ever going to need, no matter how much Java programming you do. Whereas, even by the end of the class, you'll have been exposed to maybe 10%, if that, of the Java classes that are standardized. So it's much more likely, as time goes on, that you're going to have a question about a class. It's a lot more likely to have a question about a class than about Java syntax. If you have a question about Java syntax, it's probably in that book because there isn't very much of it and they can fit it all in the book. Whereas the classes won't fit all in that book. So if you do have a question about a Java class, you can go to this URL. 1.3 refers to these J2 and 1.3 both refer to version numbers, and it's a confusing version numbering scheme. So it's Java version 2, and it's version 1.3 of Java version 2 or something like that. If you leave off the /API, it will give you links to some other documentation other than the API documentation. If you go down to API, it will give you 3 frames, one of which has a list of every standardized class that's part of Java. And then you can click on a class and it will show you about all the public methods and give you documentation on them and so on.
Can you get the source code for all this?
I think so, but I'm not sure.
Not all of it, certainly. They have their own license thing, but they don't release it all. There are pieces of it available.
Okay. Notwithstanding what Richard Stallman said yesterday, to a significant extent with a object-oriented programming system, you can have freedom number one, the freedom to modify the software for your own use, even if you don't have the source code, because you can extend. This is what you're going to learn about with inheritance. You can basically make changes to the built-in classes without having the source code. Not necessarily quite as much as if you did have the source code, or not necessarily quite as easily, but you can, most of the time, the changes that you actually want to make, you can make without access to the source code. So anyway, there's the URL. If you have a question about a class, the answer is probably there. So I want to make sure I didn't miss that. And I'm going to go back and talk about mutators.
Are there other sources, I guess, for classes besides Sun?
Yeah. I don't know much about who they are. There's a lot of places that are going to sell class libraries for specific things. So, for example, 3D graphics is a standard one. I'm not sure what other class libraries are out there, but I'm sure there's quite a few. Okay, we have this vect2d class, and it's got private double. I'm not sure if David mentioned you could do this. You can define, if you have a bunch of things that are the same type, you can define them on one line with commas. So we can say double x comma y rather than having to say private double x, private double y. My suggestion is that you only do that when there's some sort of relationship between these things, as there would be with x and y, and that you don't use it just to save space. As I'm doing here, I'm using it to save space in writing. And this is probably a lowercase g. We have get x and get y defined. And right now, this is what's called an immutable object. Once you create it with the creator, the constructor event, and you pass the x and y values to the constructor event, they can never change because there's no code on the class that would change them, and since they're private, you can't change them from outside the class. So it's an immutable object, and that makes sense for some classes, and it may well make sense for a vector class where once you have a vector, it's a vector and it's not going to change from pointing to one thing to pointing to something else. So it makes sense that you can't change it. But we're going to change it anyway because that's the example that we have. So we could add this is new x as one word. In contrast to the new operator. So we have a method here, set x, where we pass it, needs to say double. We pass it a double, and it assigns that value to x. So this is called a mutator method. It's used to change a private value on an object. And we presumably also have a set y. We might also have a third mutator where you pass in x and y, and it changes both of them. Maybe you'd only have one that changes both of them, depending on what it is that you need to do in the mutator code. And so here we would have a gatekeeper. For example, we needed to have vectors that were not 0. Then we could put code in here that would check to make sure that you weren't simultaneously setting x and y to both be 0. And that's what I was talking about before. If you just made these public, then other scripts could go in and inadvertently wreak havoc with your private variables and make them inconsistent or invalid. Whereas with the mutator function, you have control over what happens to your variables. And if there's a mistake, then you know that the mistake is inside the class and not some weird side effect somewhere else.
So when might it be good to make those variables public?
Close enough to never. Generally, instance variables on an object should not be public. They should be accessed only with the accessor and mutator methods. You might have public finals on a class to define the class's constants to the outside world so that they can be passed back in. But other than that, you would generally only have private and protected values within a class. I'll just mention one other thing about it that you can conveniently do with the mutator. We could have
It's just a regular method in Java.
yeah, it's just a regular method. It's called a mutator. Yeah. Yeah. Let's see. We could have another mutator, also called setX, that has a string argument. And we use this syntax. Actually, that's not quite the right syntax. Shoot. I thought I knew it. Maybe that is the right. Yeah, new double of new x. That works. There's a. I'm not going to get too much into the details of why this works right now, because it gets into a lot of things that we don't have. But this is basically a way that you can convert a string into a double, and so we can have a mutator that, rather than passing in a double, you pass in a string, and it assigns the string to there. So not everybody who anybody who has a string that they want to put into your vector can just call setX with a string, and they don't have to worry about converting it themselves every time. So you can it's just sort of a look ahead to various things. This is called overloading, where you have two functions with the same name, but they take different parameters.
What keywords would you use with the accessors and the mutators?
They would normally be public, because that's how people access the stuff in your class. That's what you want them to do. So you make it public. Anybody can muck around legally this way. It wouldn't be fine. It wouldn't be static, because they deal with a particular instance of the class rather than the class as a whole. So it wouldn't be static, and it would be public. Okay, we're at the end of our time. If there are any questions, I'm not going to present anything else, but if people have other questions, feel free to stay for a few more minutes and ask the questions.